Hi, Jim Berthold here again from OLI Systems with a video on solid selections in OLI Studio. The concepts here also apply to OLI Flowsheet and as well as the OLI Chemistry Wizard. So what we're going to do here today is we're just going to go ahead and add a stream, and I am going to switch to the mixed solvent electrolyte model. And now I want to determine the solubility of calcium carbonate, otherwise known as calcite. So calcite is a crystal phase that is unique. It is the most insoluble form of the calcium carbonates, and I just want to know what its solubility is. To do that, we do a precipitation point calculation found through single points. We'll change it to precipitation point, and now I have to tell it what to select. I want the solid to be calcite, and here you see we put the name calcite in the list, and I'm going to adjust the amount of calcium carbonate inflow to get to that solubility point. We'll calculate it. It runs very quickly. And over here we see we have about 1.3 times 10 to the minus fourth moles of calcium carbonate required to precipitate out a very small amount of calcite. Okay. We call that a solubility. However, in other environments, such as marine environments, the more stable form of calcium carbonate is aragonite, not calcite. So aragonite is actually formed because there's a small amount of magnesium solution and prevents the calcite crystal from forming, and you get aragonite. So most of the coral reefs in the world are various forms of aragonite and not calcite. So we're going to change the precipitate to aragonite. Okay. All looks good. We're going to run it, and it converges. But the solubility, this is the amount of calcium carbonate necessary to precipitate out aragonite, seems rather large, 1.4 times 10 to the 0th power. So it's 4 or 5 orders of magnitude more soluble than calcite. Well, if that was true, most of the coral reefs in the world would dissolve naturally, and that certainly doesn't happen. So we're going to go take a look at what happened here. We'll look at some output here, and we can see that it's got that 1.43. We can also look at sections here and pick solids. And it's telling us that the stable phase here is actually calcite. So even though I picked a different solid phase, aragonite, to form, I'm getting calcite. And this is actually one of the problems with an equilibrium-based solver, is that we're going to take the solid that is the most thermodynamically stable. We know from experience that in seawater, calcite is not the most stable phase. Aragonite is. So we have to turn off calcite. So how we do that is through the chemistry menu item and model options and phases. Okay. Now we don't list them out by name here, but we do if you expand it. So I'm going to expand all of the calcium containing solids in the model. And you can see I have calcite here. So I'm going to turn it off. I can turn lime and portlandite off as well, and I'm only going to be left with aragonite. Click OK. The model updates. You notice that the single point checkbox cleared. I'm all set to go. I'm going to rerun it. Now I look at the solubility. The solubility here is 1.5 times 10 to the minus fourth. A little bit higher than for just plain calcite, but it's giving a much better thermodynamic result. So what you need to do is you need to go through your models and check to make sure that the predicted solids are reasonable. And we know in this case here that the previous case I just ran was not reasonable. The solubility was many orders of magnitude too large. So that's how you change solids within Studio. There are similar mechanisms in the other software, all for the same reason, trying to produce a better representation of your process by tuning the unrealistic solids from forming and just removing them from the model. Again, if you have any questions, please contact us through the portal found through the webpage at www.olisystems.com, and we would be certainly happy to answer your questions. Thank you.